Hello everyone, my name is Yingkun Chu, and today I will talk about question 1 in homework 10. The first question, the question asked me to collect the definition and simple properties, such as density, mean, autocorrelation, autocovariance function, for example, of statistic process. And there are 7 processes. The first one is Poisson process. We can see that the Poisson process has the first order probability mass is just like this, and this is a mean value. This is we already know the Poisson distribution before, so this is the same like the Poisson distribution. It's mean. It's the same like the Poisson distribution, and we can just directly add them. Replace the t to the lambda t. The lambda is a parameter, just a parameter. It's not the random variables. And the autocorrelation, we have this, and autocovariance, we also have this. And the discussion of this Poisson process, the Poisson process mean is a linear function of t. Which means that the longer time we wait, the expected number of bus is larger, and it's in the non-overlapping time environment is independent. So the autocorrelation functions contains the mean value of the t1, t2, which is comes from the property of independent increment. The next function is Poisson increment process. Poisson increment process is defined like this, and xt is a Poisson process, which means that this time change in this experiment. And we have mean value is also lambda, autocorrelation, autocovariance. And the discussion of this is this Poisson increment process is a kind of increment process. It's introduced to define the Poisson impulse process. So the autocorrelation is a triangle with the area lambda, which is independent of the epsilon. When the epsilon goes to 0, the triangle becomes an impulse with area lambda. The next function, next one is Poisson impulse process. This is derivative of the Poisson process. So it have no definition. It has also the mean value, autocorrelation, autocovariance. The Poisson impulse process is just there are lots of impulse in the x-axis because it's a derivative of the Poisson process, and we may define this output of the linear time environment system. It's HT. You know that the YT is a convolution of XT and HT. It's a Poisson impulse process. And semi-random telegraph signal. We know that this just like this, and the xt, which means that k in the from 0 to t is even number or the odd number. So the first order probability matrix is this. And this is the mean value, autocorrelation, and autocovariance. And why this pxt equal to 1 is not 1/2. It's because we mainly defined this pxt is equal to 1. It's not -1. It's we define it. So this is why this is called semi-random. It's not random. It's because we define when t equal to 0, the xt is equal to 1. So the probability equal to 1, xt equal to 1 will be smaller, greater than the probability of xt equal to -1. This is because we define the xt equal to 0 is equal to 1. And so this is this one. And the next one is random telegraph signal. Random telegraph signal, which means it's pretty random. In every time we cannot not know, and there are two values, which is yt is equal to 1/2, pa equal to 1, equal to pa equal to -1 is 1/2. xt is semi-random telegraph signal. So this is a mean value, this is autocorrelation and autocovariance. So we can know that this makes us guess that yt, this is random telegraph signal, is might be a strict sense stationary, because this is a constant. And the next one is the random walk. Random walk is something like we throw a toss many times, but this effect is overlapping. Because you know that if this first time we throw a toss at its head, we write as 1, but next time if the result will be a tail, the result will be -1, so we can write 0 is 1 minus 1. So x nt is there are k times head and n minus k times tail. So we ks times 1 and minus n minus k times s times -1. So this is the result. And this is a probability method. This is a mean value, autocorrelation, and autocovariance. This is we guess when n goes to the infinity, and this is a thing like the Gaussian density. And this is also have the property of independent increasement, that non-overlapping time environments, they are independent. The next one, the Wiener process, is also called Brownian motion. This will be that the one limitation of the xt, limitation of the random walk. So this is another process. This is mean value, autocorrelation, autocovariance, and there are more properties of this. So this is a question 1 in homework 10.